Well, to kick things off, could you tell us an overview of what you do as the science director at the Boojum Group?
So I joined them about a year and a half ago when they were just doing CBD, so before the medical side started out. And the idea was we just wanted to kind of bring a scientific foundation to what we were doing, And so at the very beginning, I was doing a lot of the lab stuff. We were all kind of working together in there. And then as we've kind of gotten bigger and gone into medical, I've switched my focus more to research and just sort of trying to make sure that all the products and processes that we have a solid foundation in scientific research. On a daily basis, I'm reading lots of articles, writing articles, just kind of like looking at I like to look at, peer-reviewed journals and things like that and kind of go straight to the source as opposed to like reading anecdotal evidence and things like that, and actually kind of find out what the science is saying and how we can, put that into our product to make products that are as scientifically sound and effective as possible.
So, in fact, that they are a scientifically valid, true medicine, yes?
Yeah, based on fact.
Based in fact. I like that even better. Fact, not opinion, as people are so want to embrace rather than true science.
That's very true.
And that brings up an interesting question. Other than your wonderful blog content, of which I have read a bunch, every word greatly appreciated, really great. So I would encourage people in the green scene, if you're looking for more information, science on cannabinoids, check the Boojum Group blog.
Thank you.
Yeah. So would you help us and our readership understand what a cannabinoid is, Olivia?
Yes, that is a very complicated question, actually masquerading as a very easy question.
Right.
But I'm going to, when most people talk about cannabinoids, they're talking about phytocannabinoids, right? So phyto means plant. So these are the cannabinoids of the plant, because we also have endocannabinoids, which kind of do the same thing, but evolved very differently and have kind of very different purposes to begin with. So cannabinoids with phytocannabinoids, these are the ones that, pretty much anybody in the cannabis scene is familiar with. You've got your THC and CBD, CBG, CBC, a whole bunch of them. There are, I think, 113 to 130, depending on which information you're reading and what actually is considered a cannabinoid, because it can be more complicated than just, straight up. For example, beta-caryophyllene is an agonist of one of the endocannabinoid receptors. And so like that kind of by the definition of cannabinoid should be a cannabinoid, but it's not, it's a terpene. So it gets pretty complicated, but essentially you've got these biomolecules that are made by the cannabis plant in the trichome, so in that sticky resin. And they start out with CBGA, that's sort of the original.
The acid?
CBGA. CBGA is the original, and then that is going to get broken down by enzymes. And so the genetics of the plant decide which enzymes it has. So if it has, for example, THCA synthase, you're going to get mostly THC. It's going to turn that CBGA into THCA. Understood.
So you please continue with helping us define the complexity of what a cannabinoid is.
So when they're coming from the plant, essentially, it's interesting because in humans and in the endocannabinoid system, and I know we'll get to that later, so hopefully I'm not skipping ahead too much.
Okay.
But we define cannabinoids as essentially the molecules that are setting off the cannabinoid receptors. But then not all of our endocannabinoids do set off those cannabinoid receptors. So when we're talking about them generally in cannabis, we're talking about those phytocannabinoids, the ones that are in plants. So those are not, signaling molecules the same way the endocannabinoids are. The plants actually make them more to like repel insects and make them taste bad. Apparently it works for other animals, not humans. Also to catch pollen, things like that. It's just sort of a sticky, resinous stuff on the plant and its purpose there. But so essentially you have the like I was saying, the CBGA, and you're breaking that down. And depending on what acid the plant is using to to make that original CBGA, you'll either have CBGA or CBGVA. So CBGVA is going to turn into essentially the varin cannabinoids. So all those cannabinoids that have a V in the name, CBDVA, THCVA, and the same enzymes that break down the sort of original ones are going to be breaking down the varin ones too. So if you have a lot of THCA synthase, you're going to end up with a lot of THCA and then also THCVA. So essentially, you just have all of these different cannabinoids, and there's different versions of them with sort of, if you still have the, carboxylic acid attached. I think most people in the green scene understand, that you need to decarboxylate THCA to get an active molecule of THC. And so all cannabinoids are going to start out with that acid sort of attached. And then they're going to have different lengths of carbon tails depending on whether they're varins or not. So the plant just essentially makes all of these molecules, like I said, 113, 130, sort of depending on who you're looking at. And they're mostly making them for their protection, but we're pretty lucky that they end up working for us too.
Yeah, what a mystery that must be. I mean, I know many people throw around the word that it's, the receptor system that we have, the endocannabinoid system. And that's kind of fascinating to me. I mean, as you mentioned in your blog content, that the history of cannabis is well over, or at the very least, 12,000 years old. I noted
for a long time. Both medicinally as well as for fiber and things like that.
Apparently, most of us out here have no idea what a terpene is, scientifically speaking. Could you clarify on that? You mentioned it briefly a moment ago, but a terpene, and why is it important to medicinal cannabis?
So everybody, everywhere in the world who can smell or taste is familiar with terpenes. They just don't necessarily realize it. But terpenes are going to be the thing that, it's what makes your orange peel smell like an orange, and it's what gives your wine flavor. It's sort of those basic molecules, biomolecules made by plants that we have in all different kinds of food. So the terpenes are going to be the thing that is actually, giving cannabis its flavor, its aroma, all of those things, but also its effects. So terpenes have, they act on our body in similar ways to the cannabinoids, where they are, working with the cannabinoids to affect receptors and act on enzymes and things like that. So I find it really interesting. Terpenes are essentially what is going to give you your indica or sativa. So indica and sativa are essentially species of cannabis, but not really. Pretty much everything that we consume here in the States is sort of a hybrid, but cannabis sativa is kind of what I think they're calling it, but they're all subspecies, and comes down to kind of like what's a species and questions like that. And if they can breed together, they're really the same species. But the different sort of indica versus sativa tend to be strains that have different genetics for terpenes. So something that is, for example, will be an indica that we call an indica. It essentially just means that it's going to have a lot of myrcene in it. Myrcene is a terpene that really is kind of known for giving you that couch lock, things like that. Whereas something would be a more like uplifting strain is going to be like limonene or pinene, and even people who don't consume cannabis are going to be familiar with those, because limonene is of that very sort of strong citrusy smell, aroma, taste, whereas pinene is more that kind of pine. It's in rosemary, basil, things like that. And so all of these terpenes are going to combine in different ways to give your cannabis a very specific effect and a very specific taste.
Very cool.
And it's gonna act with those cannabinoids for an entourage effect to help them sort of act in very specific ways.
So interesting you bring up the entourage effect. A couple of questions come to mind. First of all, we're all mad to know a scientific definition of the entourage effect.
Entourage effect is basically the idea that all of these cannabinoids and terpenes are in your body. So essentially, all of these different biomolecules are going to be mitigating and magnifying each other's effects. And so you're going to end up with an effect that is more than just the sum of its parts. It's the sort of synergy of all of these different parts working together.
I was going to ask, do you know who coined the phrase entourage effect? Do we know that? Who came up with the phrase?
I'm not sure. My suspicion would be that it goes back to Meshulam, who discovered THC. He's at the Hebrew University in Jerusalem, I think.
Oh, wow.
That would be my guess, but I'm not positive about that.
Wow, how fascinating.
We have something like myrcene that's actually going to help, like THC, get through the blood-brain barrier and be more psychoactive than it would on its own. And you can find a lot of evidence for the entourage effect in anecdotal evidence. So for years, before there was much science behind it, people would say, oh, eat a mango, it'll enhance your high. And mangoes are very high in myrcene. And so now you're finally getting to the studies that are starting to look at that, and look at how does myrcene actually help THC cross that blood-brain barrier and be more psychoactive. There's a lot of different examples like that. Or, for example, taking CBD and THC together. Right. So with those, THC is metabolized by an enzyme, a liver enzyme, that CBD inhibits. That CBD induces. So CBD makes essentially more of this liver enzyme, which breaks the THC down faster. So you have a lower concentration in your blood, and your body kind of deals with it faster. So if you take CBD and THC together, you're not going to get as intense or as long of a high as if you take THC alone or with things like myrcene. And so there's so many, there's countless combinations. If you have, you're talking over 100 cannabinoids and over 100 terpenes, think of, all the different combinations that those can make. There's so many different ways that these can act on your body and different highs that they can give you or different physiological benefits.
Wow. It must be so exciting for you as a scientist. Would you say that's true?
I love it. It's super fascinating. I don't think that there are any other really fields right now that have so much potential, so much interest, so much, I don't know, it's been real, it's been since it's been outlawed since 1937. So, there's not that much research on any of this. There's very little. And all of a sudden there is license to study this really amazing interaction of things. And it's a really exciting time for sure.
Well, I am very happy that you are here doing your science. I'm going to keep very close tabs on how this evolves. So how does a medicinal cannabis scientist consume cannabis?
You got to do a lot of research. I always kind of liked smoking flower. I was kind of a traditionalist that way before I got into the science more. And I've since kind of switched over. I have a dab pen, little wax dab pen. Because when you're smoking the flower, you're losing, you're only getting 20% of the THC and CBD, the cannabinoids are even making it into your body, let alone that's not even bioavailability. That's just how much, of the smoke you're actually getting in. And then, the smoke isn't that great for you and is not good for the lungs and things like that. It's still, I feel like the other ways of consumption doesn't have quite the ritual of a joint and things like that. But I've really become attached to my dab pen. I make a solventless rosin here. So we've been kind of experimenting with that.
One thing we're curious to learn is why the entourage effect is beneficial for patients.
Why it's beneficial for patients?
Mm-hmm.
Well, for example, in the CBD and THC example, there are THC has so many benefits, but it also comes with the psychoactive side of things. And, there's a lot of people who don't want to experience a psychoactive high when they're taking their medicine. They just want a medicine that's going to get rid of the pain or the nausea or something that's just going to straight up work without giving them this whole other experience. So for that, if you add CBD in there, or if you have a solution that's mostly CBD and not that much THC, that CBD is going to counteract the psychoactive effects. Right. Or CBG, for example, it's been shown that CBG with CBD is much more effective against pain than just CBD or just CBG. So, as these things are added together, they often magnify the benefits of each other. And especially for things like pain, nausea, inflammation is a big one. And kind of the way that those cannabinoids are interacting, that's going to be a lot more effective than a single cannabinoid on its own.
Very cool. Fascinating. Wow. All right. So could you explain a little bit about how the endocannabinoid system works?
It's a signaling system, and it's one of the most important systems in the body, probably the most important one when it comes to keeping the body in homeostasis. So that's sort of a balance. So that's controlling things like pain, inflammation, hunger, all sorts of things like that. And it's really fascinating because it works sort of backwards from most systems. So, for example, the nervous system, you've got your two nerves, and where they come together, that's the synapse. And that's where messages are sent back and forth between the two. With the endocannabinoid system, you have the endocannabinoids actually being made in the postsynaptic neuron and then sending their message back through the presynaptic one. So it has great implications for kind of, it's that sort of connection between the mind and the body, and being able to kind of mitigate pain, to to kind of tamp down the signals or amplify them depending on what's needed by the situation. And endocannabinoids, are similar to phytocannabinoids in their shape, but our endocannabinoids are very specific, like messenger ligands. So they're these little biochemical molecules that are very specific to kind of sending messages around your body as it relates to keeping it in balance.
Oh. Wow. Well, that's tremendous. I love hearing this information directly from a scientist. Thank you, Olivia. Here's an interesting thought. What's the effect of a cannabinoid on a canine?
On dogs?
Yeah.
Fascinating question.
Because we love dogs. That's what Cole told me. Cole said you love your dog, so I must ask.
How did you know that?
I think it's true. You guys had a chat a while back, and he remembered it because I'm also a dog lover, and he mentioned it. He said, be sure to ask her that question.
All right. I love dogs, and animals in general. And right. It's really fascinating so the endocannabinoid system is something that all vertebrates have. So all animals with a backbone have an endocannabinoid system, reptiles, birds, mammals, all of them. Also sea squirts, which is interesting, and they go back about 600 million years. So essentially, this is a system that we've had in our bodies. It has been evolving for 600 million years, which is a lot longer than pretty much any other system we've got. And we're lucky that, other mammals share similar endocannabinoid systems, because a lot of the research is done on mice. I would say the vast majority of in vivo studies, so the studies that are done in a body as opposed to out in a petri dish or something, are done on mice. So dogs, essentially CBD has been shown to work really well on all different animals, dogs, horses, cats. It works. I use it for my dog when I go on a road trip, give her a little drop of CBD, and she just kind of sleeps the whole way and isn't nervous and panting like usual. But you have to be really careful when it comes to THC, because dogs have a lot more of CB1 receptors. So their CB1 and CB2 receptors are the main receptors in in the endocannabinoid system. And the CB1 receptors are the ones that are mostly going to be in the central nervous system. So they're going to be in the brain, the spinal cord, nerves. And those are the ones that bind to THC and give you the psychoactive effect. And dogs have a lot more of those receptors. So THC is considered toxic to dogs. Generally, they won't die if they have it, but, I think it can be a really scary experience for them because they don't know what's going on, and, don't give your dog a cookie or any, drops of THC oil or anything like that, because it's going to freak them out and it's going to be a lot more potent and powerful and scary than it is on humans. Wow.
Thank you for that. Boy, no more from my dog. Gosh. All right. Here's a serious question. How will federal legalization of your research and endowments and grants help move this forward? How will you take advantage of that?
Well, I think, it's going to move it forward hugely, because it was just, I think, last week, 2 weeks ago. Anyways, this month, for the first time, they've made it so that you can study cannabis from dispensaries, which has not been the case. So up until this month, all cannabis that's studied by researchers anywhere had to come from one grower, which is at the University of Mississippi. They grow it, and they have a program that grows it there. And so, that really is not a good way to study it, because cannabis is so diverse. Right. And, you have so many genetic strains. And again, you're looking at all these cannabinoids and all of these terpenes, and getting one type from one university for all research studies doesn't make any sense. So it's really fabulous that now people are going to be able to study cannabis from dispensaries. So all different strains and kinds, and from different places and grown in different places. The environment has makes a big difference on the cannabinoids that are there, things like that. And then the other thing is that there is a lot of money coming in. The NIH, the National Institute of Health, gave out $3.5 million to research for cannabinoids and terpenes on pain. So, with all of that money sort of coming in and opening up of what strains can be studied, it's a really fascinating time for research.
Fascinating time for patients as well.
Absolutely. Absolutely. It's all going to trickle down and benefit the patients.
Excellent. So happy to hear that, and to share it with our readership in the green scene in Salt Lake. Could you please tell us about one of the most exciting things you have discovered as a scientist working in the cannabis industry?
Well, in terms of just what I've been researching, it's interesting because even, I taught anatomy and physiology for years before coming to work here. And I had never taught about the endocannabinoid system or been taught about it throughout all of that. So that to me was a complete eye-opener, that there's this incredibly huge system. It was only discovered in 1992 that has been totally ignored. And I think a lot because of the stigma around cannabis. And so just kind of discovering that, and it is without a doubt the most important link between our brains and bodies, and how our brains sort of make sense of what's happening in our bodies, and vice versa. And so just kind of learning about that and discovering its existence more or less was mind-blowing to me, that there's this whole system that, we don't even talk about or teach students about, or, even a lot of doctors aren't really that well versed on it. So that to me is crazy.
A little remiss. Any idea, any thoughts as to why we would neglect studying such an essential system that is so old?
Well, again, I think that it is in the stigma. So it was only discovered it was kind of reverse discovered by scientists who were studying THC and trying to figure out how THC works in the body. What is it doing to give us that psychoactive effect? They weren't even looking at benefits or anything like that. It was just about the psychoactivity of it. Mm-hmm. And so, as they were looking at that, they found this receptor, CB1, that they hadn't known existed. And as they started looking around, they found CB2, and then found that these other receptors kind of worked with the cannabis plant. And essentially, that became the start of discovering the endocannabinoid system, because from there, they then were like, well, why do we have these receptors? It doesn't really make sense. Like, humans aren't going to have receptors in our body specifically for the cannabis drug, you know? So then they found the endocannabinoids themselves. So we have anandamide and 2-AG, arachidonoglycerol, these little endocannabinoids that are sending those signals around in our body. And so once they found the receptors, they found those signals, or those endocannabinoids. So, it all kind of stemmed from cannabis research, and that's something that a lot of people are afraid to talk about. And, it's been so stigmatized for years, and, research has really been tamped down on and things like that. So it's going to be really exciting to see how that all explodes, because I think it's going to have huge implications for human health.
Have you at all ever experienced any, bias within the scientific community because of what you're studying? Or in general, are people more accepting and appreciative?
I think that there's definitely, I've seen bias in the medical community. I think I've gone to speak to people and been like, you're a doctor. What can you tell me about the endocannabinoid system? Because I want to learn as much as I can. And, they often don't know that much, or don't really want to talk about it, or, things like that. I've definitely, I feel like there is a disconnect a little bit between the cannabis community and the academic scientific community. And I think that that's going to change now. I can see it changing, and there's a lot of crossover and a lot of acceptance more and more, but that stigma is still kind of there, I think.
Well, let's do everything we can to eliminate it.
Absolutely.
Yeah. Well, one final question, if I may, Olivia. You cannot be alone in your scientificness out there in the world. So we're curious to find out, what are the women you admire in the science community, especially relative to cannabis?
Relative to cannabis, I would say the rock star, I follow her on every platform that I can, is Dr. Rachel Knox. She's up in Portland in Oregon. Mm-hmm. I don't know if you're familiar with her, but she does a lot of really great work. She's a doctor, and she's sort of talking about the endocannabinoid system. She does a lot of advocacy work and things like that, and I really admire her and love everything she writes or does. She has a TED Talk that you can find on YouTube on the endocannabinoid system. That's pretty good. There's also, there's a doctor at the University of Utah, Dr. Deborah Yergelin-Todd. Hopefully I said that right. But she got an NIH grant and is studying, CBD and THC ratios in pain management and doing MRIs of patients and things like that. So that's pretty exciting, and I'm excited to see what comes out of that research too.
So are we. Olivia Kulander, Science Director at the Boojum Group, thank you so much for spending a few minutes with us today to clarify a few things we really wanted to know about.
Thank you for having me. I appreciate it.
Yeah, it's been fabulous. Hopefully we'll get up for another visit. Can't wait to come see the facility.
Yeah, I love that. We're really, really excited to show people around as soon as the virus recedes a little bit.
Okay, well, let's be sure to set that up so we can share that insight with our readership.
Yeah, absolutely. Thanks again for having me.